Hi, my name is Josh Bauman, and I'm an applications engineer at Hanna Instruments. And today I'm going to demonstrate the difference between pH and alkalinity. Now, there's often a lot of confusion between the terms pH, alkalinity, and acidity. pH lets you know if something's acidic or basic. Alkalinity and acidity let you know how much acid or base they can absorb without changing pH. For this demonstration, we prepared two beakers. The beaker on the left contains deionized water, and the beaker on the right contains deionized water with baking soda or sodium bicarbonate. So what we're going to do first is we're going to measure the pH of the deionized water. We can see the pH is starting off around 7.4, and we're going to slowly add an acid. In this case, we're using vinegar, which contains acetic acid, and we're going to add in drop by drop to see how quickly we can change the pH. With one drop, we can already see a drastic change in the pH. It went from about a 7.3, 7.4, all the way down to just over 4.5. With the second drop, we're approaching a pH of 4. The pH of the vinegar is around 3, so we're going to see how many drops it takes to drop below a level of 4 pH. The third drop drops it to around 4. And with a fourth drop, it goes below 4 pH. We're ending around a 3.9. Now I'm going to rinse off the electrode. And now we're going to take the pH of the deionized water with the baking soda. So this is starting off around a pH of 8.5, and again we're going to slowly add our vinegar and see how quickly we can change the pH. One drop and there appears to be no change in pH. A second drop, again nothing, so I'm going to start adding the vinegar in at a quicker rate. 3, 4, 5, 6, 7, 8, 9, 10 drops, and we still don't even notice a significant change. So I'm just going to go ahead and pour some of the vinegar directly in. We can see the carbon dioxide fizzling off. We've added a significant amount of vinegar, and there's still only a slight change in pH. It's dropped just over 1 pH unit. So this shows that by adding the baking soda or the sodium bicarbonate, we've significantly increased the alkalinity. So when these two beakers started off close to the same pH unit, it took a significant amount more of vinegar to change the pH at all with the baking soda as opposed to the deionized water. Here we can see 5% vinegar. If we had vinegar that was 10% acidity, it would have been the same pH, but it would have only required half the amount of vinegar to change the pH of the DI water or the DI water with the baking soda. We can see from the experiment that baking soda can be used as a way to maintain a pH level. If we had kept track of how much acid we needed to add, we could have determined how much base was in there to begin with. This essentially would have been a titration. We also offer mini acidity titrators and mini alkalinity titrators to test for just that. If we look to some real-world applications, drinking water facilities get their water from both groundwater and surface water. If we look at surface water like lakes, they tend to have low alkalinity. If we look at groundwater, that tends to have higher alkalinity due to the rain going through the ground, percolating, and picking up minerals along the way, like magnesium carbonate and calcium carbonate. Some of the major areas of applications for alkalinity testing are in cooling towers, digesters for wastewater treatment plants, and groundwater facilities. Thank you for watching the video, and for more information, go to www.hannainst.com.